Okay, students, so welcome to today's class. I hope I'm audible to all of you. Okay, yes. So some students are replying here. If I see it, yeah, good afternoon, Anu Kumari and Shushri. Okay. I hope I'm audible to all of you. I hope my audio is clear. Is it fine?
Yes, sir.
Okay, very good, very good. So let us check on YouTube also. Because YouTube is also important, no? Okay, let me check there on the YouTube what's happening there. So we started the class fine here with no issues. Some students have texted me something. Okay, yes, fine, good. So everything is fine, audio is fine. Somewhat if you see about the video, like video is somewhat like, it's different. Okay, leave it. Class must be visible, okay? So students, I have launched a techno poll. This is techno poll. Please participate in this techno poll. It's really important. Please participate in the techno poll. Participate in this poll. Don't waste time. Participate. Participate. All of you must participate. Hai na? Our class is on time today with no issues. Okay. So our YouTube links here and here we go. Yes. So let me see on the YouTube. Is everything perfect going on there? Okay. So let us start now. Okay, students. So you all have participated in this poll. I'm ending the poll. Okay. Yes, I'm audible in the slides that are properly visible to you. So that's fine if there are no issues here. I've ended the poll. I see screen ke samne like poll screen must not come. Okay. In front of your phone screen, the poll screen must not come. Poll means, I mean, you're not able to, if something is interrupting you and this PPT slides, so it will create a problem for you. Got it? Okay. I hope it's clear. So now we'll start it with full energy. Okay. Yes. So chat. Yes. Okay. Okay, students. Now, no, I'm not wasting time. Don't worry. See, if you see the revision part, sir, ये तो बहुत बार हो गया, 1000 बार हो गया. Like this you have completed so many times. It's very boring now to again and again repeat the same thing. Same students, I am feeling fear. Okay, same I am feeling. It's really boring doing the same things again and again. Okay, so we'll not do that today. Okay, this is completed 100%. Let us put a stamp here. Okay, it's cleared. It's cleared. Next, our next mission was yesterday's mission. Yesterday we have like destroyed this target. Okay, I mean we have completed this. Then we have destroyed some important terms also. We have completed this target. We have put our flag here. Okay, Avanti flag. Next what? Next are the numericals. Numerical students, I mean, these numericals were pending. You know this thing, isn't it? The numericals were pending. Got it? So now we'll be studying numericals. So today's class session will be complete numerical. You will see a bunch of numericals here. Okay, like, dozen of numericals. Okay. So today we'll work with pen and paper. Got it? So every one of you take out your notebooks and pen or pencil, whatever. Okay, because now I will give you a question. First of all, I'll solve, then I'll give you. And if you're able to solve, then it's okay. Otherwise, I will give you the solution in the class. Don't worry. Got it? Is it fine? Yes or no? No. Yes. Yes. No. What? What is your answer? Okay. So, so this was the contents of, I mean, this is the content of today's class. Okay. This is what, this is the content of today's class. That, sir, our session will be complete numerical. Complete numerical session will be there today. Next, what? Next, we'll be studying if our numericals are completed. What are the numericals? Is 7, 8, 6, which I have selected. It's been automatically selected here and put on the slides. And like, you know, if we are able to complete that before the time, that is 4 p.m., then we'll study somewhat about the refraction. And if we are clear with the definition of the refraction within the time limit, then we'll also see animation. Very interesting. Sorry, very interesting animation. Got it? I hope it's clear to everybody. Okay? Now let us move. Yeah, sir, complete हो गया, आगे चलो. Yeah, sir, complete हो गया, आगे चलो. Sir, move next. 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 Now, students, we have where were we in the previous class? I told you that I will give you a question. I have given you a question as a homework, and then I told you that I will take this question as a recall question in the next class. Okay. So we see now our recall question is yet to come, and it's coming. Yes. So students, yes, this question was solved actually, na? Sorry. So which is our recall question? This is our recall question. Is it fine, students? So now we'll be solving this question. Got it? Yes, I told in this previous class, I'll, students, just take this question as a homework, and I'll ask you this question tomorrow as a recall question. And tomorrow is what? Tomorrow is today. Yesterday's tomorrow was today. Okay. I mean, yesterday, tomorrow was, it is today. Okay. Is today. So if there is some audibility error, I mean, if you're not able to hear my words properly, please text me in the chat box. Otherwise, keep silent and note down the things. Also understand the concept. Main thing is a concept. Okay. Now let us revise our previous class concept with this recall question. Let me write it here with very beautiful handwriting. Recall question. Okay, students. So black pen. See what you're able to see here. Which kind of mirror is there? Sir, it is a spherical mirror. Okay. Which kind? I mean, which type of spherical mirror it is? Is it concave or convex? Anyone? Which type of spherical mirror is it? Concave or convex? What do you say?
Concave.
Very good. Yes, very good, very good. Riya says concave, Anu says concave, Lakhan says concave, Shumshi says concave, and Shreya says concave. Good, very good. So it's easy, we can predict, we can just see the things and we can get it. It's concave. So see, this mirror is concave mirror, okay. This already they have given this point as 0, 0. 0, 0 matlab hota hai origin, okay. Ye O, this is pole or vertex here. So if we go from origin towards the object, if we go from origin, say pole, towards this object, okay, we'll get the object distance, which is equals to what here? Okay, Sonali have already given the answer. She says that like this key, it's 10 centimeter virtual image. Okay, we'll see. Okay. So students, all the students who got the answer, please have patience. After the solution, you can cross check the thing. Okay. Yes. So if we move here, we are having the magnitude of the object as 5 centimeters. But object is 5 centimeter. That's fine. But it's a magnitude. Okay. And we also need to put the sign here. Sign will be minus 5 centimeters. Okay. Okay, students. Fine. So blue pen is the best pen. Maybe. So we'll use the formula 1 by V plus 1 by U equals to 1 by F in a very good handwriting on the slides. And we know this thing, ki sir, U is here minus 5 with sign and conventions. Focus, actually in the magnitude sense, it's R by 2, which will come out to be 10 centimeter. But it's curved, this mirror is curved like this. Curvature is here. Okay. So it's tilted towards the left hand side, students. ठीक है. It means if you go from pole origin towards this radius of curvature side, okay, we are going negative. So I will say focus with sign and convention will be -10. These two things now we need to put here in this equation, and then we'll get V, our answer. Okay, so let us put it and solve the question. So when we will put this thing here, 1 by V plus 1 by U equals to 1 by F. Okay, students? Now what? Sir, now what? Now what? Nothing, but it's F equals to -10. Okay? And U equals to minus F. If you put this values down, if you put this value down, what's going to happen? 1 by V minus 1 by 5 equals to minus 1 by 10. So this you will get as 1 by 5 minus 1 by 10. So from this, students, you will get the answer as what? You will get as 1 by 10, 1 by V. This V is what? Now from here you can see this, that you are actually getting this answer, which is a positive answer. And positive means positive means that where the image is. So if the mirror was like this, okay, concave, and this is principal axis, this is object. No, this is pole. This is Mr. Object, okay, at a distance of 5 centimeters. And focus here is 10 with magnitude, sign and convention minus. Image is positive. It means if the origin was given here and the image we got as plus 10 centimeter, it means image will be here plus 10 on this axis in front, okay. And I will say image is say somewhat here of this object. Image is here and it is at 10 centimeters, okay. It is at what? It is at 10 centimeters. So I will say, if I want to write the answer, I will write how the answer I will write. Okay, one student have texted me something. Varsha says virtual and erect. See, Varsha, virtual and erect, that's fine, but it's not required for us to comment here, because you know what was the reason? Because it's a point object. It's a point object, and point object will be having a point image. So how if dimensions are like this, a negligible kind of dimension? Basic point is what? What are the dimensions? You will say dimensions are like negligible. Limit tends to 0 kind of, but not 0. Got it? So image also will be having this kind of dimensions. So what erect, what inverted? Nothing to say. Just distance will be there. Virtual or distance in the sense positive हुआ तो virtual, negative हुआ तो real. Real negative मतलब यहीं पे इसी एक्सेस पे इस साइड में, पॉजिटिव मतलब इस साइड में virtual. ठीक है. So they are asking found the position. Sir, position तो हमें मिल गया. Position is 10, but with sign and convention minus sign. So minus you can read in the physics language as virtual image. Virtual image. Okay. Is it fine, students? Yes or no? Please text me if you understood this recall question, because recall question is really important. You understood this? If you understood this thing, please text here. Okay? I hope it's clear to you. Who is this? Okay, Sneha have texted yes, Nali have texted yes, and other students have also texted yes. That's cool. Okay, just wait. Let me see on the YouTube. Some students are asking doubts, I think. Yes. No doubts. Hello. Okay. Yanshika, you have raised the hand. Is there any problem? Was I audible to you, I mean, throughout the lecture properly or not? Okay, fine. Just wait for a second. Just wait for a second. Okay, now students, I'm giving you one question now in the class to solve. Try to solve this question. Don't find the height because you don't know the theory concept required for finding the height, but find the position and the type of image. Leave this for now, okay? I'm removing this thing. So for now, just remove this thing. I have removed just for now, okay? ऑब्जेक्ट का डिस्टेंस दिया हुआ है, फोकस दिया है, फाइंड द पोजीशन एंड द टाइप ऑफ इमेज. इट्स अ क्लास illustration, CI. It's a class illustration. Solve it. Solve, and like I'm just seeing what happening on the YouTube. Okay. Solve. Zoom students, also the YouTube students, solve this question. I request everyone to solve. Yes. Anybody is able to solve this question? Okay. So Sonali says 5 centimeter virtual. Varsha says 5 centimeter virtual. Okay, students, very good. You are solving it. Shows your, I mean, how much you're interested in this topic physics, or like also you are how much passionate towards your competition, that is ITG and NEET. Okay, got it. Yeah, Monali have also texted. So now we'll see how to solve this question. Okay, got it. So students, I am now, yes. So we were here, let us erase everything. Okay, we'll see. You people got some answer for the position. You people got some answer for the, what for the 5 centimeter virtual is your answer, right? It's fine, students, but we'll see. Is this answer right or wrong? Just have patience. We'll see that is your answer right or wrong. Okay. But before solving this, see, you can solve this question if you know the theory related to these two concepts, that is position and the type of image, by using the formula 1 by v plus 1 by u equals to 1 by f. Okay. But you can't find the height of the image. So what's the method to solve these kind of numericals when you are given the object? If you are given the object, with the object distance, you can do something. With the focus, you can do something. But what about the image? I mean, you will get the image position. But if the height of the object is also given now, which is 4 centimeter, then how you will find the height of the image? This is now a big question. We don't know how to solve it. Okay, no need to cry. So what we're going to do is this. First of all, we'll study a little bit of the theory related to this. Okay. So we are going to study a theory concept first. Then we'll switch back to this question. Then we will switch back to this question and solve it again. Okay. Okay. So now write a heading before solving this question. I will give you a theory, little bit of the theory. Okay. So write this heading, students. Transverse magnification. Transverse magnification. First of all, we'll study this theory and then we'll switch back to that numerical and solve it. Okay. Write this heading: transverse magnification. Magnification. Transverse magnification. Okay. See students, suppose you are given a concave mirror like this, and suppose there is a principal axis. This is suppose pole or focus, not pole or not focus. It is what? Pole or vertex. We say like this, it is suppose pole or vertex. Okay. And suppose focus is here on this axis. Okay. And we know focus is at r/2 distance from the polar vertex. And we talk about if I extend this line, of course, this principal axis is extended this. And then there will be a point here C, which is at from this pole, it is at r distance, that is radius of curvature. Okay, got it, students? Now, if we try to find the image of the object. Okay, suppose we are given an object. I'm just taking the random case. Okay, remember, I'm just taking the random case here. Okay, don't think that I'm solving the question now. It's a random case. Suppose a object is placed here, which is having some height. Suppose it's like a sword kind of thing. Okay, it's a pen. Okay, suppose it's a pen. It's a pencil. Okay. Having one thing is common, it's having a position also, u. Suppose the distance from the pole is u, object distance. Focus is given for to you people. You can find the image distance by using the formula this. Okay. But students, let's see here, look now. If this is also having a height of the pencil is say HO, because it's an object, so I'm writing the subscript as O. Okay, height of the object is O. Okay. So how will find the height of the image? So remember, I'm giving you here a short trick. Okay, it's a formula from a complete kind of derivation, taking the laws and all this in theta, and all these things. But I'll give you the formula, use that trick. So whenever you get a question in which the height of the object is also given, so you can find the height of the image through that. Okay. But before that, understand this thing. If you are from this principle, sign and conventions. So first of all, let us talk about the sign and conventions related to the height. First of all, let us talk with this for the sign and conventions related to the height. Suppose this is principal axis. If we go perpendicular up to the principal axis, this direction is positive. If you go down with respect to perpendicular down with respect to principal axis, this direction is negative. Okay? This direction is positive. This direction is negative. Take. So the formula is this: height of the image. Remember it always with magnitude. You have to put the proper sign and convention, students. Height of the image, height of the object divide karenge. You will write like this: minus V by U. This is the formula, well-known formula of all times. Okay. Height of the image upon height of the object equals to minus V by U. Okay, students? Height of the image, height of the object minus V by U. You have to put in this formula proper sign and conventions. With proper sign and conventions. You have to put this here and then you will get the answer. Okay. Now we'll apply this in the application in the previous PPTs of that numerical which I've given you. So this was the numerical, no? Now no need to cry, it's time to be happy because now we know that yes. Now we know what? Now we know this thing, yes, we can solve this question. So it's time to be happy. Okay, so let us solve this question now. See, now I'll be very fast, focus here. Object का distance कितना दिया है? U is how much here? It's by the way convex kind of mirror. Okay, it's a convex mirror. Okay, so Ria got the answer, Monali got the answer. Good, very good. Let us see what other students do, but let's wait, have patience. Okay, I'll solve it, then you cross check the solution. This is by the way convex mirror. Okay, and if you stand on the pole, if you go towards the object, you're going against the direction. So you'll take this as object distance, and object distance u is minus 10 centimeters. Focus here is basically at this point. So if you go towards the focus from the pole, if you go towards the focus from the pole or vertex, it's in the direction of the rays, that is positive. Okay, so we'll say focus is positive, that is 10 centimeters. Okay, and object is minus 10 centimeter. So now you need to put these values and then you will get the V first. Okay, so you can see here object is minus 10, F is 10. So let us put these values. Formula क्या लगाएंगे? Formula we know. It's a common formula for concave mirror or convex mirror. U कितना है? Minus 10. F कितना है? Plus 10. Solve it. How much do you get, students, here? V is equals to 2 by 10, 5. So from here I can conclude V, it's plus 5 centimeter. It means the position of the image, just position, not height. So I can comment here that the position of the image is here, students, plus 5 centimeters, positive. But what's the height of the image? Because height will also be there, no? So let us put the, now apply that formula which we have seen. That is height of the image, height of the object minus V by U with proper sign and conventions. See, going for height of the image object, if you go from the principal axis perpendicularly, this direction is positive. Okay, so height of the object is 4 centimeter here. Okay, V is what? V will be what? V will be, we know the answer, it's 5, positive 5. Put positive 5. U is what? Minus 10. So these values I'm going to put here. Okay, okay, I can solve it here only, no need to go on the next slide. So you can see here plus 5 के आगे minus भी है. So minus 5, minus 10, minus cancel. 5 1 is 5, 2 is 10, half. So height of the image you are getting as 4 centimeter by 2 centimeter. That is 2 centimeter. So height of the image is 2 centimeter. That is half of the height of the object, but on other side, and it's half. But it's erect. It's not laterally inverted. Got it? So I will write the answer as this, that position of the image is 5 centimeter plus, and the type of image is virtual. It's not inverted, it's erect, same, but on the different side. Height of the image is half of the height of the object, that is 2 centimeter, because height of the object is 4 centimeter. Okay, a complete answer if you want to write, you could write like this, that the image is virtual, erect, finish, and magnitudes are 5, 2. 5 is the position, this is the height. Okay, some students have texted me something. Shreya, your answer is perfect. Varsha, perfect. Riya and all the students. 8 answer. Why did you get 8 answer? 8 is not some anywhere here. Okay, you're not having the 8 anywhere here. Okay, fine. Okay, students, now we'll be solving this question. Okay, first of all, text me. Are you able to understand all the things which we have studied till now? Till now, are all the things completed? I mean, in your mind, I mean, you're able to understand. What are the things which are completed in the class? Are you able to understand all those things or not? Okay. So some have replied, yes, sir, yes, sir, yes, sir, yes, sir. Okay, fine. Now I'm closing this video. Okay, write a new theory topic now. Velocity relation. Write this thing as I'm writing in front of you. Velocity relation of image, object, and spherical mirror. And spherical mirror, students. And spherical mirror can be anything. It can be concave, it can be convex. Okay? Write this heading, then I am giving you a derivation. Remember the derivation, then we'll solve the numerical based on this in today's class only. Okay? So class is going on with a good flow today. We have solved 2 numericals at least. Okay? See, suppose students, we are given a concave mirror like this. Okay. And principal axis is this. Okay. Suppose you know this thing, pole or vertex, focus, curvature. Suppose now the object is here somewhat. It's a kind of ball and it's moving. Suppose this mirror is also moving, say Vm. The spherical mirror is moving some vector speed, say vector velocity, you can say, because it's vector quantity, Vm. And this is moving with, say, Vo. Of course, it will be having some image. I don't know. It can be here. It can be here, wherever. Okay, suppose it is here. Suppose. So it will be also moving with some, say, Vi. So what's the relation connection between Vo, Vm, and Vi? See, why there will be connection. We have also seen this thing that in the case of plane mirror, if the object is moving like this, image will be moving, and we know the relation, velocity of object, velocity of image. In the helicopter case, did you? I mean, do you remember that thing? Let me show you. Okay, see this. Dun, 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 where it is, where it is, where it is, where it is. See here. Yeah. Solo. So this. Okay. So by using this funda, we have derived this thing, velocity of object plus velocity of image upon 2 is velocity of mirror. So this was the relation for plane mirror and object and image. Okay. Got it? And now we'll find the relation for spherical mirror case. Same thing for spherical mirror. What is the new formula? Same thing for spherical mirror. What will be the new formula? Okay. So now let us derive the new formula. So we'll say like this. First of all, let us see the mirror formula, which gives the object distance, image distance, and the focus. इसको करो differentiate. इसको कीजिए differentiate. Just do this differentiation. I mean to differentiate this with respect to time. We'll get like this, minus 1 by v dv by dt minus 1 by u square du by dt. This is constant. Focus we know it is constant. It's based on the curvature. Okay, so it is 0. Constant का rate change कितना होता है? 0. So this will get answer as velocity of image with respect to mirror. You will put here as spherical mirror. Mirror is equals to, by the way, this will be positive here. This will be negative sign. So minus v square upon u square, velocity of object with respect to mirror. This is velocity of image with respect to mirror. This is velocity of object with respect to your mirror. Okay. So this is a connection, minus v square upon u square. ठीक है? Is it okay? Is this formula fine, students? I derived fast due to the lack of time. Will it work? If it's okay, then I'm just going to show you a question. Will you be able to solve it? If it's okay, then I'm going to solve a question. I mean, I'll give you the question. Fine. Okay, this is a question in front of you, students. This is the question. Apply that formula and then you will get the answer. Okay. So what you are given here? You are given here speed of this mirror, that is velocity of mirror, spherical mirror is minus, take this sign minus, of course it will be minus, and we know the sign and conventions. Minus 1 centimeter per second. Focus, it's a concave mirror, so focus will be negative with sign and conventions. Object distance u minus 30. Object speed is positive, this direction is 2 centimeter per second. Okay, let me write the direction. It's positive. From the pole, it's negative. So 2 centimeter per second positive. So now we have all the things. We need to apply the formula. Okay. Formula was this: velocity of object with respect to mirror, not ground frame. These are all the things VO, VM are from the ground frame. Sorry. This is velocity of image. Okay. So we say like this: velocity of image with respect to mirror minus v square by u square, velocity of object with respect to mirror. Got it, students? Now solve, apply the formula and you'll get the answer. Okay, so Shushri says, let's try. Okay, students, so you try yourself. I'm giving you 5 minutes to solve this. Okay, try it yourself. I'm giving you 5 minutes to solve this question. I mean, in 5 minutes, we both will solve, you and me, okay? You and me in the sense, first 2-3 minutes for you, last remaining 2 or the 3 minutes for me. So our time starts, it's already been started, 30 seconds have already been over. Remaining time, 4 minutes, 25 seconds. 4 minutes, 20 seconds. 4 minutes, 17 seconds. 4 minutes, 5 seconds. 4 minutes. 3 minutes, 54 seconds. So are we able to solve this or not? Okay, some students have texted me something. Let me see the answer, where they have given me the answer or not. Okay, so Sonali have given the answer 0.25 centimeter per second. Okay, so we'll see that is your answer right or wrong. Okay, so now I'm solving this question. All of you just look here on the slides, PPTs. Let us solve this question and end the class. Okay, we'll solve this question and end the class. Maybe we'll end the class. So what it says. So you can see this question. It is concave mirror, है ना? So first of all, what are the things? Let us expand this formula. So it will give us velocity of image minus velocity of mirror. If I'm going to expand this formula, it will give us this thing. Minus v square by u square. Velocity of object minus velocity of mirror. Okay. And see here, if now what are the things which we are having actually in this question? We are having velocity of mirror -1. We're having velocity of object, that is also fine. But we are not having velocity of image, which is our actually requirement to find, है ना? Velocity of image तो हमें ढूंढ नहीं है because it's already given in the question on the top. And this is what? This is concave mirror. And what are the rest of the things which are required for us to solve it? We have u, object distance. We don't have v. So first of all, we'll find v. Once we put here v, the rest of the things we are already having. That is velocity of mirror, velocity of object. V put किया, u भी है, ये भी है, ये भी है, ये भी है. We'll get this thing, which is our requirement, which is our demand of this question. Okay. So now let us see. First of all, let us find v. 1 by u, 1 by f. F is how much? F is -10 here. U is how much? U is -30 here. V we need to find -1 by 30 -1 by 10. जब हम इसको सॉल्व करेंगे तो हमारे पास आएगा 1 by 3 -1 1 by 10. So you will get here as what? -2 by 3 10. Okay, -2 by 30. So from this, if you solve, you get v as -15 centimeter. V is equals to -15 centimeter. Okay. So students, now using this v in the formula. Which formula? This formula. If v यहाँ put किया, u तो है ही. So okay. Let us now apply the formula. Expanded formula. Velocity of image minus velocity of mirror minus v square u square. Velocity of object minus velocity of mirror. Because these terms which you are able to see were the compact form. No, velocity of image with respect to mirror. Velocity of object with respect to mirror. ठीक है? Velocity of image is, see, image का velocity हमें ढूंढना है. Object का velocity क्या है? 2 centimeter per second and 1 centimeter for that. So mirror का है -1 centimeter per second. Velocity of image is a requirement. V कितना है? -15. It's not positive. You can see it's minus. It's minus. See one more time. Minus. U कितना है? -30 का square. Because it's u means -30 -3. V मतलब -15. Object कितना था? It's what's moving 2 centimeter per second, है ना? See this 2 centimeter per second positive. So minus velocity of mirror -1. जब इसको solve करेंगे, this is +1. This is -1 by. I am solving directly fast mathematics. This is -+3. Velocity of image. This means what? This means, or you can write it velocity of image with respect to ground. That is R frame. -3 by 4 -1. So it is -7 by 4 centimeter per second, which is the 100% perfect answer. So this will be your answer. Anybody got this answer? Please raise your hand or put a text in the chat box. Let me see who are all these students. -7 by 4 will be the perfect answer of this question. ठीक है? Okay, Anu got the answer. Very good, Anu. Excellent. Very good. Okay, बहुत अच्छा. So we can say like this: if concave mirror was like this here, if the object was moving with 2 centimeter per second, if the object was moving with 2 centimeter per second, and the mirror is moving with 1 centimeter per second, image will be moving with, and where the image is at basically minus 15. It means here only. Object here, image here, it is moving with minus 7/4, मतलब negative ऐसे 7/4 centimeter per second magnitude, but in opposite to object direction. ठीक है? This is image. This is how image will look moving. Object is moving, mirror is moving, image will be moving like this. Object, image. ठीक है? I hope it's clear. Yeah. Manali, you have raised the hand. What are you having any question? Or simply raised? Now, students, this question. Okay. Suppose we are given an object with the coordinates. See, till now we were solving the question which were having the object distance from the mirror, that is pole, from the pole or vertex, or they were having height also. But from these coordinates, what you can extract, what the information which is coded in this that you can decode from these coordinates, what is the information? Information is this, students. That is, this is having coordinates. What does it mean? It means, see, origin is also given. Origin means what? Origin का मतलब तो यही हुआ ना. Origin का मतलब क्या? Origin मतलब कि this is positive x-axis, it's positive y-axis, it's negative y-axis, and it's already given positive x, negative x. ठीक है? Pole जो है इस concave mirror का pole, it is at origin 0 0 0x 0. Now they're giving the coordinates of the object as minus 41. What does it mean? It means like this, that इसका x coordinate minus 40 है. मतलब 40 magnitude पे in the negative direction from the pole. And इसका y coordinate plus है. That is, this is 1 centimeter. So you will can be interpreted, or we can say like this, interpreted, and like can be asked like this now, students, key if the height of the object, is plus 1 centimeter, means like up from the principal axis, because this is positive direction from the principal axis, this is negative direction from the principal axis, on both of the sides. I mean on both of the sides, either here or either there. Okay, it's either here or here. Plus 1, and the object distance here is given as minus 40 with sign and conventions. This is also with sign and convention. These two things are given. Also, you're given radius of curvature. It's a concave mirror. So going from the pole towards that side, radius of curvature will be there. Center of curvature is there, of course. That's why the radius of ROC will be there. F will be there. F will be minus R/2. That is minus 5 centimeter with sign and conventions. So we have all the things required with sign and conventions. Now they're asking you this thing. Find the position of the image. That is, find the coordinates of the image. Can't you find? Very easy, no, now, because we have changed the question. Okay, basically they're asking you coordinates means find the V image distance from the pole and find the height of the image, and then by seeing the coordinate system, adjust the coordinates of that. You got it? जैसे इसमें से coordinates से we have decoded the height of the object and object distance. Similarly, you have to reverse that thing. First find the height of the image and object distance, then translate, or sorry, convert that into coordinates that they're asking from you. Find the image coordinates, x and y coordinate of the image, by keeping this Cartesian coordinate system, जहाँ पे origin 0 0 pole पे है. This question is a homework for you, students. Got it? So it's finished for today's class. Note this question and then tell me, are you able to understand today everything? I mean, huh? First of all, do you understood this question? How to do this? This is a homework question for you. Tomorrow, sorry, whenever the next class will be there, I will take this question as a recall. Is it fine? Yes or no? Nobody's responding. What's the issue? I have to end the class. No, respond, please. Yes, sir. Yes, sir. Yes, sir. Okay. Anu says, Sneha says, okay, Manali says, okay, fine. Now, students, this is a question. Not if you have noted down. If you noted it down, then that's fine. And fine. Okay. Now, students, that was all about today's class. Thank you so much for your participation in the class. Okay. Now we have some few more minutes. If you're having any doubt, you can ask. Or just rest of the students just participate in this poll. I have launched the poll. The rest of the students may participate in this poll. I have launched the poll, and if anybody is feeling any doubt, can ask. Today we had complete. I mean, we have just recently completed our full numerical session. I mean, the session was completely overloaded with numericals. Okay, but somehow we have completed the numericals based on spherical mirror. Last question is the last question. I mean, last concept, which is connected with the solution of the when we are solving the numericals based on spherical mirrors. And after that, no concept is required. I mean, question now can't be made by some other manner. Okay, this is the fusion of many concepts. The last question. And now from next class, we'll start reflection, taking this last homework question as a recall. Any doubts? Okay, thank you everyone. Thank you Anu and all the students, Share and all the students. Thank you all the students, okay? Sonali and all the students, Monali, okay. Okay, students, so thank you everyone. Now we are going to end the class. Bye-bye everyone. And we have solved all the numericals. So today target is completed. Now we'll meet in the next week. Till then, be happy, chill, and okay. So bye-bye everyone. Bye-bye. This is hand, dinosaur hand, okay? Okay, I'm ending the class. If you're not having any doubt.